So let's look at this problem right here. This question is asking the current at the terminal of the element in figure 1.5 is I is equal to 0 when t is less than 0, I is equal to 250t e power minus 2000t milliampere when t is greater than or equal to 0. A is asking find the expression for the charge accumulating at the left terminal, and the B is asking find the charge that has accumulated at t is equal to 1 millisecond. Okay, here they are mentioning a figure which is nothing but a picture that is given in the book. That's a simple picture. So you don't even need this. I'm just drawing. Okay, plus minus. Well, this is the picture provided in the book. Let's look at this one here. Here they are saying when I is equal to 0, t is, when t is less than 0, I is equal to 0. And when t is equal or greater to 0, I is equal to 250 t e power minus 2000 t milliampere. Okay, and we know that there's an equation for the current. Current is nothing but differentiation of the charge, which is dq by dt. If you differentiate the charge, that will give you current, and that is given by this right here, 0.25, because this is milliampere. If I convert it to ampere, this is going to be 0.25. Then t e power minus 2000 t, and that's going to be ampere. And then if you rearrange this equation, then you know that dq is going to be equal to 0.25 t e power minus 2000 t dt. Now this is in differentiation, so to eliminate this one we had to do the integration. If we do the integration for the differentiation, it will both will cancel and you will get the q. So here if I do the integration, the starting line is when q of 0, and then goes up to q of t dx. Okay, and which is going to be 0.25. Only the terms which contains the t is going to be integrated, so I get the numbers also because this is just a constant, and then integrate 0 to t, and then here we use the x, here we had to use y or some other. Y is going to be good, y e power minus 2000 instead of t I'm going to put a y, and or you can put t as well, but it will complicate everything. That's why we put y here, y e power minus 2000 y, and then dy. Okay, so if we integrate this one, let me continue over here. We know that integration is going to be the difference. So first we have qt minus q0, and then in the other side we are going to have 0.25, and when we integrate this one we are going to have e power minus 2000, and when you integrate an exponential we will have the power in the denominator, so we are going to have the negative 2000, and that will be squared as well. Okay, and that one multiply by, I'm not having enough space here, so I'm going to go and continue in the next page. Maybe I copy paste this one. Okay, let's bring it over here. Okay, let's continue. So we will have e power minus 2000 over minus 2000 square, and then also multiplication, which is minus 2000 minus 2000 y minus 1, and it goes from 0 to t. Okay, now we have done the integration. Now if we simplify this one, we are going to get here, this is going to be negative 2000 square. So if you square this one and divide by this one, you're going to get 62.5 times 10 to the power of minus 9. and then e power 2000 ti. Okay, this is t right here. Okay, not t here because I didn't apply the 0 yet. I mean t and 0 yet. So if I apply t first, okay, if I apply t first, all the term that contained the y will be multiplied by t. So here there should be a y here when we integrate, minus 2000 y, and that one should be multiplied, replaced with t when we input the t. Okay, and then this negative 2000, instead of y we are going to have a t, and then minus 1, and then this is for when we apply the t for the y's. When we apply 0 for the y's, this is going to be e power 0, which is 1, but this one remains. So if you divide 0.25 by this one square, we will still get the 62.5. okay, and so on. So I put plus here because the thing is here we have negative 2000, and then if we apply 0, the whole thing is going to be 0, and then here this is negative 1, and we are looking at the difference. So this is this t minus 0, like here q of t minus q of 0, the whole term minus, so the minus make it into plus here. Okay, then we are going to get 62.5 times 10 to the power minus 9, and this term is, we know that this term is going to be 0, but this power, this remains 1. Okay, so nothing else comes, only this 62.5 times 10 to the power minus 9 is going to remain. Okay, now we can further simplify this one. So in order to simplify this one, we can multiply this e power minus 2000 t with this bracket. If we do that and then take the 62.5 times 10 to the power of minus 9 common, then this one becomes a 1. So I put that 1 in front, and then this is going to be negative 2000 t times e power minus 2000 t, and I write it as it is, negative 2000 t e power minus 2000 t, and this minus 1 multiplied by this one, that's going to be negative e power minus 2000 t. Okay, and that is qt minus q0, and q0 is by hypothesis, q0 is actually 0. It's when time 0, what's the q is 0, so it's going to be just qt representing all these things. So instead of qt minus q0, we can also write this one as q of t, which is equal to 62.5 times 10 to the power minus 9 times 1 minus 2000 t e power minus 2000 t minus e power minus 2000 t. Okay, that's the a part. So this is our final expression for the charge. Okay, and the b part is asking, find the charge that has accumulated at t is equal to 1 millisecond. Now what we need to do is, instead of this t, we replace that t with 1 millisecond. Q, instead of t, we are going to replace 1 millisecond. 1 millisecond is 0.001 second. So we can put 0.01 here, and then 62.5 times 10 to the power minus 9 remains, and then 1 minus 2000, and instead of t, we replace that one with 0.001, and then e power minus 2000, instead of t, we replace that one with 0.01, and then minus e power minus 2000, 0.001. After that, you just need to do the calculation. Once you do the calculation and simplify this one, you're gonna end up getting 37.12 nanocoulomb, and that's going to be the charge when when the time is 0.001 second. That's 1 millisecond. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.